Hello, welcome back. This is a video summary of our previous lesson on how to calculate a limiting reagent, how to determine a limiting reagent or reactant, excess reagent, how to calculate a percentage yield, how to calculate percentage error. It should be noted categorically that in real life, when reactants are reacting in a chemical reaction, not all the reactants are going to be used up before the reaction goes to completion. It should be noted that during a chemical reaction, there is a particular there is a reagent or a reactant that will be used up first, and the rest will be left. The reagent that is used up first in a chemical reaction, we call it a limiting reagent. This is a limiting reagent. And the one that is left before the reaction goes to completion is the reagent, we call it the reagent in excess. So when, let me say, two reactants or two reagents are in a chemical reaction, there are, one is used up first, and that is a limiting reagent, and the other one is left, and that is the one in excess. Okay, you could be asked, you could be given a reaction, their masses, to determine which one is a limiting reagent and the one which is in excess. There are two methods of calculating a limiting reagent. Given the reaction, given their reacting masses, the first method you will use in calculating which one is a limiting reagent, the first method you use in doing that, one, you have to calculate the moles. You have to convert the given masses of the reactants into their various moles. When you convert them into their various moles, then you now divide their various moles by their molar coefficients, the coefficients in a balanced equation. In that balanced equation, there are some reacting moles. You now divide the given moles by their reacting moles. That's what we call the molar coefficient. When you divide them, the one that has a higher mole, a higher value, will be the one in excess. And the one that has a lower value will be the one that is a limiting reagent. Method number two, you can still use this, this other method in determining the limiting reagent. This is by doing what we call mass to mass conversion. You have to convert one mass of the reactant to the mass of the other reactant. There are four stages in this. Given the mass of one reactant, you will have to divide it by its molar mass to have the moles of that reactant. Then you times the moles of the reactant by the mole ratio. You have the moles of the second reactant. And then you times the moles of the second reactant by its molar mass. You have the mass of the second reactant. You now compare the masses and see which one is limited in the reaction. And by doing that, you can determine which one is limited. So these are two methods in calculating a limiting reagent. We will do that by using some examples. We will do that by using some examples. Take, for example, we have a reaction between ammonia. This is a reaction between ammonia. Determine the limiting reagent if 100 grams of ammonia and 100 grams of oxygen are present at the beginning of the reaction, which is the limiting reagent. The first thing in every stoichiometric calculation, you have to write a balanced equation. If you write a balanced equation, then you will know their molar coefficients or their reacting moles. Secondly, you can use the method of dividing the moles of ammonia. We can use dividing the moles of ammonia, the mass of ammonia by its molar mass. The mass of ammonia that was given is 100 gram divided by its molar mass, which is 74, which is 17.04 gram. We will have the moles of ammonia, and that will be the moles of ammonia. And when we have the moles of ammonia, we will divide it by 4 to have it by 4, which is the molar coefficient, and we will have the final number of the value that is reacting. Then we will go for oxygen. Oxygen is 100 gram. You will divide 100 gram of oxygen by 32, which is the molar mass. You have the moles of oxygen. When you have the moles of oxygen, you divide it by its molar coefficient, which is 5. You have the value. You compare the two values. The one that is higher is the one that is in excess. The one that is lower is the one that is limited, and you take that as a limiting reagent. Method number 2, you can use a mass-to-mass conversion to have the limiting reagent. For instance, in our equation here, we have 100 grams of oxygen reacting 100 grams of ammonia. 100 grams of this. In order to calculate mass-to-mass conversion, we have to convert the mass of ammonia to the moles of ammonia, multiply by the mole ratio to have the moles of oxygen, and then times the molar mass of oxygen to have the mass of oxygen that is required for complete reaction. For instance, here, 100 grams of ammonia divided by 17.04 grams of ammonium times 5 all over 4, which is the mole ratio. That is 5 all over 4, that is 5 moles of oxygen reacting with 4 moles of ammonia. Then times 32 grams of oxygen, we will have 235 grams of oxygen. So 100 grams of ammonia will require 235 grams of oxygen. But in the equation, they said 100 grams of ammonia reacting with 100 grams of oxygen. If we compare the value, for this reaction to go to completion, it will require a total of 235 grams of oxygen. But we were given only 100 grams of oxygen. In this case, oxygen is less in the equation that was given. So we consider oxygen to be a limiting reagent. Once more, the calculation reveals that you need 235 grams of oxygen to completely react with 100 grams of ammonia. But you have only 100 grams of oxygen that was given. So oxygen will run out first before you run out of the ammonia. So the oxygen is the limiting reagent. That is how you get it. To identify the excess reagent as well. From here, you now know oxygen is limiting. It's a limiting reagent, and ammonia is the excess reagent. That is a simple fact. To do it. Another example of this, another example here is given here. Let's do another example here on the blackboard. On the blackboard, let's do another example, please. Here you will see there are many examples of such category. From here you can do that, and you can do that. Here, this is another example that is given here. We have in a reaction like this one, the equation we just solved. We have from the combustion equation, this is propane. Combustion of propane to give carbon dioxide and water. This completes combustion. Now, in the reaction, 32 grams of oxygen reacts with 11 grams of propane. What is the limiting reagent? 2. Calculate the theoretical yield of the water in grams. 3. Experimental yield gives 100 grams of water. What is the percentage yield? And 4, what is the percentage yield? In this reaction, the first thing is a balanced equation which was given. We have here 11 grams of propane reacting with 32 grams of oxygen to produce carbon dioxide and water. The molar masses, the MRO of propane is 44 grams per mole. The MRO for oxygen is 32 grams per mole. The MRO for carbon dioxide is 44 grams per mole, and the MRO for water is 18 grams per mole. How do we determine which one is a limiting reagent? The first method, which I said, calculate the moles of, from the given masses, calculate the moles of the two reactants. Then each mole, you divide it by its molar coefficient. You will have you have a value. Then you compare the value. The one that is higher is in Excel. The one that is has a lower value is the one that is a limiting reagent. And this is the method. Method number 1, we are calculating for propane. The mass of propane that was given was 11 grams reacting with 32 grams of oxygen. So 11 grams divided by its MRO, 44 grams, will give us 0.2 moles of propane. Then if we have to divide these moles of propane by its molar coefficient, propane has just one mole of propane reacting with 5 moles of oxygen. So if we divide the moles of propane by its molar coefficient, it will be 0.25 divided by 1, which will be 0.25 moles of propane. Then let's go to oxygen. The mass of oxygen that was given is 32, and its molar its MRO is 32, and 32 divided by 32, we have 1 mole of oxygen that was reacting. We have 1 mole of oxygen that was given. Now, in order to divide this 1 mole by its molar coefficient, oxygen from the equation has a coefficient of 5. We divide the 1 mole by 5, and it will be 1 divided by 5, which is 0.2 moles of oxygen. Now, 0.25 moles of propane and the 2 moles of oxygen. We know that 0.2 moles of oxygen is less than 0.25 moles of propane. Therefore, oxygen is a limiting reagent. That is how you can determine a limiting reagent using this method. Method number 2, you can use mass to mass conversion. In that case, you are going to convert the mass of, there are 2 reactants, propane and oxygen. Mass to mass conversion. You are going to convert the mass of propane to the moles of propane by dividing 11 all over 44 times the molar ratio, which the mole ratio will be 5 all over 1. We'll have the moles of oxygen, and times the molar mass of oxygen will now have the mass of oxygen. That is the mass of propane to the mass of oxygen. Let's do it like this. We do it here like this. Method number 2. The moles of grams of propane is 11 divided by 44, which is the MRO. We'll have the moles of propane. When we times the moles of propane by the molar ratio, which is 5 all over 1, we will have the moles of oxygen. When we times the moles of oxygen by its MRO, which is 32, we will have 40 grams of oxygen. Then, compare the values now. 11 grams of propane required 40 grams of oxygen, but only 32 grams was given for the reaction. We can still conclude from here that since for a complete reaction, 11 grams of propane will require 40 grams, because oxygen was only 32 grams of oxygen was given, we say oxygen the limiting reagent. That is the second method in calculating the limiting reagent. Number 2, calculate the theoretical yield of water. Remember, a yield is a product. A product can only be got from something that is completely used up. And anything that is completely used up, agent. And from the reaction above, the limiting reagent was oxygen. So we are going to calculate the theoretical yield, but from using the reaction between propane and the oxygen gives carbon dioxide and water. So we are going to concentrate from here, from oxygen to propane. From oxygen to water. So the first method is if 5 moles of propane, 5 moles of oxygen were completely used up to produce 4 moles of water. Then 1 mole of oxygen that were given in our reaction, that is 32 divided by 32, 1 mole of oxygen will give how many moles of water? Once more, since we are calculating it from the limiting reagent, which is oxygen, it is now a limiting reagent, which is oxygen, which are completely used up in producing water. We now say, simple proportion, 5 moles of oxygen, which were completely used up to produce 4 moles of water. Then 1 mole of oxygen that we calculated will give how many moles of water? If we do that simple proportion, 5 moles of oxygen gives 4 moles of water. Then 1 mole of oxygen that was calculated will give 0.8 moles of water. These are the moles of water. In order to have the mass of water, we multiply the moles by the molar mass of water, and the MR of water is 18. So 0.8 times 18, we have 14.4 grams of water. This is the theoretical yield. Remember, we were told something here that in our calculation we were told experiment yield is 10 grams of water. Experiment gives 10 grams of water. And now we want to calculate the percentage yield now. We want to calculate the percentage yield now. Percentage yield is the actual yield that was given divided by the theoretical yield. And what is the theoretical yield? The calculated yield of water times 100. So the actual yield that was given was 100 divided by our calculated yield, which is 14.4 grams, times 100, we will have 69.4 grams, 69.4% percentage yield. That is how you can get your percentage yield. Then percentage error. Percentage error can only be got by deducting it from 100. So 100 minus the percentage yield will give us our percentage error. So 100 minus 69.4, we will have 30.6%. This is the percentage error. A recap. One, a limiting reactant or a limiting reagent is the one that is used up or runs out first in a chemical reaction. Then an excess reagent or a reactant is that which will remain after the limiting reagent has been used up. Secondly, you can calculate the percentage yield, or you can calculate the product or the yield, but from a limiting reagent. You use the limiting reagent in calculating the yield. Thirdly, in calculating the percentage yield, it is the actual yield divided by the theoretical yield times 100. And fourthly, you have the percentage error by subtracting the percentage error. You have the percentage error by subtracting the percentage yield from 100. So percentage error will be 100 minus percentage yield, and you have it. That is how you can calculate limiting reagent. You can calculate a limiting reagent and know which one is a limiting reagent and an excess reagent in a reaction, and how you can calculate the yields, the various yields, their percentage yields, and their percentage error. Thank you very much. Next time, we will do more examples. Bye-bye.